Hi, my name is Juliet Sanchez, and today I'm going to be doing a science project on slime. But first, let's talk about the science behind it. Slime is a polymer, which comes from Greek words polis, which means many, and meros, which means parts. So polymer means many parts. Now the molecules with the molecules with polymers come together with our different molecules, which come together and make a bond, a chemical bond, in fact. But and whatever they make depends on the strength of the bond. To start off with, a very strong bond makes plastic. A medium bond makes rubber. And a weak bond makes slime. Now, all of these have a chemical bond that makes it strong. Now, let's talk about glue with slime. Slime has to be made with glue, or not, but glue is also a polymer. Glue is called PVA, has PVA molecules, has polyvinyl acetate molecules. These polyvinyl acetate molecules are short for PVA. Now, these PVA molecules make chemical bonds, and they make strands like this. Now, this is only two, just because this is only two of an example of many. And in the middle, this is water. Water also is an important ingredient inside glue. It separates all the PVA strands from each other. So water makes it liquidy. And when the water evaporates, those PVA strands come together and harden, making the glue that helps you stick together your papers. Now that we talk about some of the science behind slime, let's start making it. We'll use this polymer to help. We're going to take a glue, and we only need just a little bit. Okay, and that's all the glue that we need. Now, let's talk about the activator. The activator is the part that makes slime. Now, the very important ingredient in all of our activators is sodium tetraborate. Now, sodium tetraborate is in Staflo. It's in all of these household products. Staflo. Staflo is a liquid starch for your laundry. Now this helps you, this is a liquid starch for your laundry. But if you see over here, it has sodium tetraborate. Now, what about saline solution? Saline or contact solution. Right, as you see right here, there's also sodium tetraborate. And you use this for your eyes. And then, of course, borax, which is also used for your laundry. Borax is 100% sodium tetraborate. Sodium tetraborate. But today, I think we're just going to use Staflo, because with these other two products, if you're ever going to use them, they have a second ingredient that you need to use with them. Baking soda is needed to use saline solution. And borax needs water to dilute it. But today, again, we are going to use Stay Flow. As you see, the glue is sticking to the sides of the bowl. But, oh dang, if we add Staflo, it starts to clump together in the middle and unstick. So much that if we pick it up, it won't stick to our fingers. Of course, it's going to be a little bit sticky at first because it's still forming into its glue. But the real question is, how did that happen? Now, while I'm still kneading this, I'll explain it to you. When you use your sodium tetraborate, it takes your two PVA strands and it connects them and bonds them together, all of them, making it less sticky. Making the well and loved slime. But of course, it's still going to be sticky at first before you knead it. And now it is unsticking from my fingers because I've kneaded it for a little bit. Still a little bit sticky, but if it needs to be less sticky, I just put it back inside the Stay Flow bowl and mix it a little bit more. Now slime has substances like a solid and a liquid. But the question is it a solid or a liquid? Well, the answer is it's neither. Because it's not a solid like our countertop, or liquid like my water bottle, or like the liquid inside, or like the water in my water bottle. It is actually a non-Newtonian fluid. Non-Newtonian fluid. And the non-Newtonian fluid means that it has properties of solids and liquids. So, if I take this, non-Newtonian fluid depends on the pressure you put on force. For example, if I take it and I quickly stretch it, it rips. But if I slowly stretch it apart, it stays together. And if I put it on a downhill, it'll start dripping. Now, the non-Newtonian slime is like a liquid as well, because it takes shape of its container. For example, we have this glass jar right here, or cup. Let's put it in, and let's see it set. It takes shape of its container, simply because it is also liquid and a solid. Now, if you could excuse me, I have to wash this off my hands. Juliet! Juliet, where are you? Juliet!
This cake is so good.
I really could use some milk. Milk! That was the best milk I've ever had.
To go.
It is a what's the next word?
Newtonian. Cut.
And it actually is neither, because it is a
Cut.